In this lesson, we're going to consider what happens when firms earn profits or when they get negative profits, sometimes called losses, and how that affects their decision to shut down or keep operation. We're going to use the cost curves to describe this and find the profits and losses very easily. Remember, the cost curves are just this kind of diagram here, where we have the marginal cost curve, upward for the most part, little dip at the beginning, average total cost curve, and average variable cost curve, with quantity on the horizontal axis and dollars on the vertical axis. And this particular characteristic, this particular shape, is a key thing for understanding how the firms will adjust over time. Now let's first make this curve, make this cost curve structure diagram go to work to find the profits of the firm that's operating in a competitive industry. So to do this, we're going to work the following way. We know the certain things about profits and losses, that they're related to total cost and total revenue. So for example, profits is defined as total costs minus profits is described as total revenue minus total costs. If that's positive, the profits are positive. If profits are negative, then you say that's a loss, in which case total cost is less than total revenue. So we're going to use the diagram to find out if the firm is making money, earning profits or not. So to use the diagram, we're first going to find the profit maximizing level of output, and as usual, we're going to use the condition that the firm adjusts so that its marginal cost equals its price. Then we're going to find total costs. We're going to do that by simply multiplying average total cost times the quantity produced. And that gives total cost, of course, because average total cost is defined by total cost less quantity. So you multiply average total cost times the quantity and you get total cost. We're going to show that average total cost times quantity is the area of a rectangle in that diagram. Then, having considered the cost, we're going to go and think of the revenue. We're going to find total revenue is just price times the quantity produced. And we're going to see that P times Q is also the area of a rectangle. And then finally, profits or losses is going to be the difference between the two rectangles, the difference between revenue and costs. So let's just look at the diagram first and then examine how you actually create this from scratch. So on the horizontal axis is quantity and the vertical axis is dollars, which represents either the cost or the price. You can see your marginal cost, average total cost, and average variable cost quite clearly in the diagram. Now let's go through the various steps. So first of all, you're going to divide out how much to produce by setting the marginal cost equal to the price. The market price is illustrated by the flat line towards the top of that diagram. And that flat line is flat because the price is taken as given by this firm. Marginal cost equals the price determines how much is produced, which is labeled on the horizontal axis quantity produced. Now, to get the point on the curve that represents cost and revenues, we need to go up from that point and look at the average total cost curve. So average total cost at that level of production is indicated by the arrow pointing to the place where the vertical line intersects the average total cost curve. Average total costs times quantity is total costs, and that's indicated by the hash lines in the picture. Then the revenue is just the price times the quantity. So the price is the horizontal line at the top, multiply by the quantity, and you get total revenue, which is represented by the shaded green area. Now in this case, profits are larger than zero, or positive, because total revenues are greater than total cost, as you can see. So it pops right out of the diagram. Total revenue, P times Q, total cost, average total cost times Q, the difference being the profits. Let's do that from scratch and see how it actually is computed. So I'll do two axes. One's going to be the quantity, and one's going to be the price, so I'll just put dollars up there for that, for either the price or the cost. So I'll do my marginal cost curve as usual. I'll do the average total cost curve as usual, and then I'll stick in the average variable costs as well. So we know if there's a particular price in the market, which I can represent there, that's the market price, call that P. then the firm will produce at a point where marginal cost equals the price. And so that's the amount that's actually produced. And so we can drop a line down to the axis, and that line represents the quantity produced up there. Let's call that just the quantity produced by the firm. Now, to see whether there's profits or losses, we first want to go and find out what average total cost is that quantity. And average total cost is right there. We can mark that in the diagram going across. And we now have a picture of the profits. Profits are equal to revenue, which is the price times the quantity. And so let's mark that off that way. That's that whole section there. That's revenue. And the costs are the average total cost times the quantity. And so let's mark it off that way. Okay. And the area above, which I'll just do squiggles through like that, represents the profits. Okay, so we got the same idea in the picture, and we're able to use this finally nice little diagram to compute profits. Now, the same thing is true when you consider a less favorable situation for the firm, and that's where it's got negative profits or losses. So this is the picture of that, and I've got, again, the same old marginal cost, average total cost, average variable cost pictures. But notice now in this picture, the price is lower than it was in the first picture. And so the level of production is still going to be determined by the place where marginal cost equals price, but it's going to give a different revenue and cost picture. So I've labeled in this picture the intersection of marginal cost and price. That determines the profit maximizing quantity produced, which is marked on the horizontal axis. Now you got to find out the average total cost, and so to do that you go up until that vertical line intersects the average total cost curve. In this case, you can see the amount of total cost as the area marked by the hash marks. Revenue is going to be the price times the quantity. We can see the price is that horizontal dark line, and multiply that by the quantity gives you the rectangle that's shaded in green. So in this case, costs are greater than revenues by the amount that is shown in the area loss at that point. Total revenues, P times Q, is the green. Total cost, average total cost times Q is the hash marks, and the stuff sticking above is a loss. So we've indicated how you can compute negative profits as well. And you can draw the same diagram to do that. Why don't we do that quickly so we can see what's going on one last time here. So you got these two axes. You got the quantity, and you got something in dollars. You got marginal costs. You got your average total costs, your average variable costs, which is supposed to park through the middle as well, getting closer. And now what we want to do is say, oh, let's suppose the price is lower than before. Let's suppose it's down there. Okay, so that's the amount that's going to be produced at the intersection of the price and the marginal cost curve. So we come down, we get the amount produced by the firm. Average total costs are now up here, though. And so average total cost times the quantity, let's just mark that off there. That's the total costs. And the revenue is price times quantity. That's this stuff over here. It's getting straightforward. And now that stuff at the top is negative profits or loss because costs are greater than revenues. Let's now summarize what we've done in one picture at a time. So this one takes those same curves and considers three different prices. And of course, we're illustrating losses and profits, positive profits and negative profits. So over on the left, you have the situation where the price is high enough that the firm's earning positive profits. That's the green shaded area. And the curve on the right is a situation where the price is lower, and in this case, the firm is losing money because average total cost is higher than price. That left and right-hand side are just what we've derived a few minutes ago, just replicated in this diagram. Now, the one in the middle is in between, obviously, and the price now is drawn at a point which just touches the average total cost curve. So there's a price between the one where there's profits and between the one where there are losses. In this case, you can call this the break-even point, because price being equal to average total cost of the level of production, and note that marginal cost is equal to the price there. That's the condition of profit maximization. But the price is at just the point where average total cost hits its bottom, so price equals average total cost, and there are zero profits. We call this the break-even point. And notice when we say zero profits, it may sound a little strange, zero profits means a case where economic profits are zero. Economic profits always must include the opportunity cost of doing something else. If you're running this moving company firm and you're making zero profits, zero economic profits, that includes your opportunity cost of going to work somewhere else. So your accounting profits could very well be positive. That's the value, basically, you get of running this firm. And so when we say profits are zero, we mean economic profits are zero. Accounting profits could very well be positive at that point. But the key here for incentives and what we're going to focus on is the idea that economic profits are zero. And then finally, let's consider another set of prices with the same firm, the same cost curves. So here I've got three cost curves, exactly the same as in the previous diagram. They should look the same by now, getting somewhat routine. But now I'm looking at prices which are even lower, or maybe even lower than before. So in the far left, we have the price at the place where the firm produces being lower than average total cost. And so this is a case where, as you know, there's loss. Profits are actually negative, average total cost higher than the price. And we're moving into the next picture, and now I've drawn the price at the bottom point of the average variable cost. So at that point, average variable costs are equal to the price. And then on the far right is a case where the price is even lower than average variable costs. Now we call the point in the middle the shutdown point. And the reason for that is, in the short run, a firm has to pay its fixed cost, has to pay the capital for those trucks or for those buildings. And so it will stay in operation for a while as long as it's covering its average variable costs. So over on the left, while it's losing money, it's earning enough money on each item produced that it should stay in business. It's actually getting some extra money by moving another piano, even though its total is negative because it's had to pay the fixed cost for the moving vans, etc. If you go to the next far right now, then the price is so low that you lose extra money every time you move a piano. You have to pay your workers, and you're getting less than you're actually moving the piano than you're paying the workers. So in this case, even in the short run, you should just shut down. You're losing money every piano you make. And then finally, in the middle is the so-called shutdown point. It's just in between. It tells you when price goes through that level, you should just shut down. Price below that shutdown point, shut down. Price above that, you shouldn't keep in operation. Now, of course, this is all the short run where you got that fixed capital out there you paid for. And the question we want to address in future lessons is what happens when we move from the short run to the long run. Thank you.